continuous life annuities. When we are talking about the life annuities, it means that we are looking at the periodic payment for whole life. The easy example is the pension scheme. Okay, so now how are we going to get the present value for these life annuities, the actual present value of these life annuities? Let's assume that the payment is $1 per year and then it will cease upon death. Okay, so for example, you have a timeline here, 0, 1, 2, 3. Every year the payment would be $1, but the $1 is paid continuously. So that means that it will be paid at every little small interval here, and the total would be $1. Okay, so what we are interested in is what would be the APV, or the actual present value of this annuity. So if you look at the normal annuities, okay, if you look at the normal annuities, you are going to get A bar N, which is the discounting of all of the end payment if you have end payment, which is 1 minus over delta. It will be the same case for the life annuity. It's just that your end is no longer certain. For now, your end will be the future lifetime, how long the person is predicted to live. So your end will be replaced by the future lifetime. So for APV of this, let's assume that the present value of the random variable equals to y. Y is the present value of all of the future lifetime. If you refer to the common annuity equation, so you are going to get this is equal to 1 minus v tx over delta. What the insurance company is interested in is the expected value of y. What would be the average value of this annuity? How much that the insurance company is expected to pay. Okay, so when we are talking about the expected value, it will be equals to expected of the whole thing here, which is 1 minus v dx over delta. So expected of a constant is still a constant, 1 over delta. Expected of 1 is 1 minus expected of tx. As we know, expected of tx is big A equals to 1 minus A bar x. So we can say that expected value of this continuous whole life annuity equals to 1 minus A bar x over delta. And it has a common notations. For the actual notation will be A bar x, where x is the age. This is one way of determining how to get the present value of expected present value of the annuity. Another way of determining this present value is through the integrations of the PDF. So we know that this is the expected value of y, and y is the annuity payment. So if we integrate each of these annuity period by period or interval by interval, you are going to get A bar t fxt dt, which is, we know that fxt is equals to tpx mu x plus t. So you are going to get A bar t tpx mu x plus t dt. So it will cease up until this would be the time that it is the probability that it will cease. So we are integrating from 0 up until infinity because it is whole life. And the third way of determining this is looking at the probability of surviving. As I mentioned just now, it will be paid once the person is survived, and then it will be ceased once the person's died. So as long as the person is surviving, then he will get the annuity payment. So discounting all of the, because it is $1, so I did not write here, we are assuming that it is $1 per year. Discounting all of the payment, and then times with the probability of surviving. This is another way of determining the actual presence value of this annuity. Next is how to determine the variance. Variance of this annuity is not like the insurance part. Okay, so we know that y is 1 minus VTX over delta, and the expected y is 1 minus a bar x over delta. So when we are looking for the variance of y, this is variance of 1 minus v dx over delta. So variance of a constant is 0. Variance of constants times vtx, this one you are going to get 1 over delta square variance of vtx. Variance of vtx we have known in the previous video, which is we got it from the insurance part. Okay, so which is 2a bar x minus a bar x square over delta square. Okay, that's it for this video. Thank you.